to 4.2. Let's do exercise number 1. Find the determinant using cofactors for this 3 by 3 matrix. Label and find all the cofactors you use. Okay, we've seen that we could take a cofactor expansion along any row or column as it is. Let's take advantage of that 0. We can either go along the second column or the third row. How about we go along the third row? And the computations will be equivalent. So let's take a cofactor expansion along the third row. We take a cofactor expansion along row 3 so that the determinant of matrix A, okay, we'll take matrix entries times cofactors. We're taking along the third row this entry, this is the 3-1 entry, the 3-2 entry, the 3-3 entry. So we'll take A sub 3-1 times a cofactor A sub 3-1 prime plus A sub 3-2 times a cofactor A 3-2 prime plus A sub 3-3 times a cofactor A 3-3 prime. Hey, where's the alternating plus and minus stuff? It's in the cofactors. Okay, so we'll have to find those cofactors. Here comes the alternating plus or minus sign. So we'll consider cofactor A31 prime. Okay, that was by definition -1 to the 3 plus 1 power. There's your alternating positive negative sign times the determinant of the associated minor matrix. We'll go to the 3-1 entry, eliminate the row and column. That'll leave us with a little minor matrix, 2, 1, -1, 4, 2, 1, -1, 4. All right, -1 to the 4th power is +1. So silly to write it, but I want to see the alternating plus minus sign. Let me put a positive there. We have 2 times 4 for the determinant of the 2 by 2 matrix. 2 times 4 minus 1 times -1. That's 8 plus 1. That's 9. All right, so that cofactor is 9. Let's move on to A sub 3-2 prime. A3-2 prime. Okay. Not entirely sure we need it because we're trying to take advantage of the 0. Let's go ahead and compute it for the record. So I do want to see the alternating plus minus stuff. So we'll get -1 to the 3 plus 2 power times the determinant of the minor matrix. Okay, we're looking at the 3-2 entry, 3-2, that's this one. We'll eliminate the row and the column, and we're left with a minor matrix, 5-1, 1-4. Okay, -1 to the 5th power produces a negative out front. Main diagonal, 2 by 2 determinant, 5 times 4 minus back diagonal, 1 times 1 leaves us with 20 minus 1 with a negative out front leaves us with a -19. Okay, we need the A33 cofactor. Okay, that'd be -1 to the 3 plus 3. Notice it's -1 to the 6. Let's flop back to positive. Times the determinant of the minor matrix. Eliminate the 3-3 entry. Leaves us with a minor matrix 5-2, 1, -1. 5-2, 1, -1. Okay, -1 to the 6th is positive. 2 by 2, 5 times -1 minus 2 times 1. It's -5 minus 2, -7. they wanted us to find the cofactors. So we found the three cofactors, 9, negative 19, and negative 7. Returning to the original question, determinant of A, we just need to do the arithmetic. So, determinant of A is A31, which is 3, times A31 prime. A31 prime is 9, plus 0, A32. So, like I said, we didn't need to find this thing down here, this negative 19. I guess we did to answer the question they asked. To compute the determinant, we didn't. Plus 2, A33, times A33 prime. So up here is negative 7. Okay, that gives us 27 plus 0 minus 14. 27 minus 14 is 13. Determinant of that matrix is 13. So, computing determinants using cofactor expansions, I can go along any row or column. It really doesn't matter if I'm not going to take advantage of the zeros. The arithmetic will be equivalently complicated. But I could go along the third row or the second column. And we really didn't need to do this computation here because we knew that 0 was coming. We'll be taking advantage of zeros whenever possible. So much so that we'll go and introduce zeros in matrices with row reduction to streamline all this arithmetic.